2. All right, 1, and let's go. Trigonometric ratios. I guess I'll continue this topic. It's a topic which you will be doing both in grade 10, kind of as an introduction, and then in grade 11. And if you want the introduction video, I guess I'll put up a link up above in terms of just defining the basic trigonometric ratios. But you see them here on the screen in red on the bottom right. Now, in this video, what I'm going to try to talk about is, because trigonometric ratios are defined for right-angled triangles, they're just really ratios between sides, so the lengths of sides of a right-angled triangle. So as you can see here, so if we know the opposite, adjacent, and hypotenuse sides with respect to a particular angle, we can define these ratios of cos, sine, and tangent as, you know, adjacent over hypotenuse for cos, and so on for the others. So that's nothing new, okay, if you've watched the introduction videos for this. Now, the next question is, you know, in math, sciences, you know, engineering, even in business. So as you continue on, what has happened is that these trigonometric ratios are actually not just for angles, which are going to be less than 90 degrees. And your right-angled triangles, they're going to be for less than 90 degrees, because then it won't be no longer a right-angled triangle. So the question now arises, like, what if you wanted to find and define a trigonometric ratio for sine of an angle of 135 degrees, or maybe a cosine of an angle of 210 degrees, or maybe a tangent of 300 degrees? Does that actually have an answer, or is there a ratio associated with that? And the answer is yes, all right? So mathematicians kind of came along and they said, okay, well, we're not going to just restrict these angles between, you know, 0 and 90. We are going to make them larger, and I'm going to try to show you in this video how you can remember them, you know, slightly in an easier way, all right? So in order to remember, one of the key tools that we utilize is kind of graphing our triangles and basically creating like a coordinate system. So we have a vertex which would be at the origin. You know, you have your kind of your x and then your y coordinates. And now you can pretty much plot any triangle you want, you know, with one of the vertices being kind of centered right on the origin. Okay, so I'm going to kind of put a dot right there on the origin. And so within here, if you imagine that this is your hypotenuse right there, then I can create a triangle which is going to be with respect to the x-axis, to the flat line. And that triangle, so if I drop this down, all right, so make a perpendicular and then connect this, and now all of a sudden I have created a right-angled triangle. And my angle, so in this case, the angle that I want, okay, would have been, so this is, let's say, my angle theta that I am interested in, all right? And from here, well, we can just go ahead and define our sine, cosines, and tangent like we did with the ratios of, you know, opposite over hypotenuse, adjacent over hypotenuse, and so on. But the video is not centered on that, because you would just be repeating the same thing. Now, our question is, well, what if, you know, you start moving this, okay, so this angle, let me remove this right here, but what if you move this and you said, well, I want to create a triangle that's much bigger, okay, so I want to, let's say, create a triangle, let's say that's something like that. And now my triangle is going to be this. So my triangle right here is, so with respect to that, okay, would have been this triangle. Now, the first thing that you should right away observe is the fact that, well, this isn't a right triangle anymore, and you're correct. And because it's not a right angle triangle, then we technically can't really use sine, cosines, and tangent for this, because right angled triangles are the only ones that we can use for sine, cosines, and tangent in terms of ratios. But clearly, you know, an angle like this, so this angle right here, which is going to be bigger than 90 degrees, can exist. And in fact, I mean, you can create these angles and make them bigger and bigger and bigger Okay, if you like. I mean, of course, you can go all the way around. Okay, so you can go to 90 degrees, 180 degrees, 270, 360, come back, and then, recircle. So you can go around this circle and circle. Okay, so you have those dots around there. But, so for instance in here, let's take, and I guess, that first one. So if I go back here and scroll, let's say that we did want to find, what this actually is. Sine of 135. And how do mathematicians define this? So let's say now, my angle is 135 degrees. Okay, and I have this triangle, which really I can't work with. So what did the math, ladies and gentlemen, come up with in terms of trying to figure out how am I going to now define this? So I'm going to erase, this particular triangle right here. And instead, okay, so what the math folks have done, they said, well, if you extend it past 90, then technically we can still create a right angle triangle. It would just be the complement of the actual triangle you were talking about. And that complement would have been this. And that would have been the actual complementary triangle that you have. Now, of course, we now have, so this would be my new theta, which isn't the theta I want, right? So if this is 135 degrees, then I guess my theta, so in this case, theta would have been 180 minus 135, which I guess is 45 degrees in this case, and that's my new angle. And now I can go ahead and create my sines, cosines, and tangents for the angle of 45 because it is once again between 0 and 90. So I have no problem, right? In fact, I know exactly what sine of 45 is. I know exactly what cosine of 45 is. And I know exactly what the tangent of 45 degrees is. So I can find those. Those ones are kind of the ones that come up quite often. And I did a video on those when the angles are 30, 45, and 60. I'll put up a link up above there. Okay, the answer's here, if you don't remember. So it's 1 over square root of 2, okay, and so on, and then tangent is just 1. So I'm not going to go over that and why that's the case. You can just go back to that link if you want. But these are clearly the definitions of sine of 45, cosine of 45, and tangent of 45. But that's not what we wanted. We wanted the sine of 135. We want maybe the cosine of 135, and then the tangent of 135. And they can't be exactly the same because it wouldn't be the same exact ratios. The angles are actually different. So how do we define them? So what we've done is the following. So what we said is, we said this. I'm just going to take one. I'll move it down here and I'll come back to the others. What we said is this. We said this really is just sine of 180, okay, minus, the angle. In this case, it's 45. That's what really sine of 135 is. And if you look at this and you think about this in terms of the x and then the y coordinate system, you notice that this isn't in the first quadrant, right? So, here is my first quadrant, here is my second quadrant, here is my third quadrant, and then this would have been my fourth quadrant. Now, I do know something about these quadrants. In particular, I know what the signs of my x and my y values are, right? So I know that in this quadrant, everything is positive. And notice that's exactly what we had for all our ratios, right? For degrees which are less than 90. Now in the second quadrant, well, the x is now negative and the actual y is positive. So the height is positive. So in this case, if I was saying right here, this is now my opposite, this is now my adjacent, this is my hypotenuse. Now, so my adjacent, technically, I guess it's negative because it's in the negative quadrant. Now, it's not a negative length because we can't have a triangle, right, with negative lengths. All it's telling us is just that the orientation, okay, is on the left-hand side and it's not on the right-hand side for an angle of, let's say, 45 degrees or any other angle. So what the math team has done, they basically said, well, in that case, since now we still have a right-angled triangle, and if you really want to define these ratios, trigonometric ratios for greater than 90 degrees, then what we're going to do is we're going to assign a sign to the opposite, adjacent, and then hypotenuse as well. So for instance, so in this case, if you wanted to know what the sine of 135 is, it would have been, okay, so in this case, all we do is we're going to say, well, this is the same thing as sine of 45 degrees, because you're still going in the up direction, right, in here. So it's still positive, okay? Your opposite is still positive within here. So this actually is equivalent to sine of 45 degrees, which is still 1/2. And that would have been really just the ratio between the opposite and then the hypotenuse that is given. So that's what happens. So when the angles are bigger than 90, we're actually going to take on the sine of whichever quadrant it starts to fall. So if it's going to be between, over 90 and less than 180, so if it's within there, so basically, okay, you're falling into the 180 minus whatever angle that you are creating here, the actual value for your adjacent is negative. So that means your cos is going to be negative, okay? But your sine is positive because it's going in the up direction. That's what you have actually within here. All right? So my answer to this, so sine of 135, is defined as, so basically you're taking, this is 180 minus, okay, the angle that you want, which in this case is going to be 45. So this is what we have, and it's equivalent to that sine of 45 degrees. Okay? So that's the first thing. So that's what I just wanted to let you know, that what we have is that any angle that you will find, okay, so for instance, 180 minus, okay, the theta. So if it is between, this case, 180 and 90, so if it's falling in between that range, which 135 is, this is the same thing as just simply taking the angle, okay, of the complementary. Now, for your cosine, so if you take your cosine of that same angle, now your cosine is the adjacent, right? Cosine is adjacent. But adjacent is, okay, on the negative side. It's not pointing up, it's pointing to the negative. So that means that this is actually going to be cos of the angle, but it is negative because it's on the negative side. So if we wanted to take the cos of 135, it would have been negative 1 over the square root of 2. And now tangent, so for our tangent of 180 minus the theta, in this case, because tangent is just opposite over adjacent, or sine over cos, right? So in this case, so what that means is you can take the tangent of the angle and it's going to be negative. Because notice, if you divide and you take sine and you divide it by cos, well, cos is negative, sine is positive, so the actual answer will be negative. And that's how you can remember, okay, this particular structure. All right? So it's an identity in between, and you do see this quite often. Now, what would happen, okay, if you continue this? So I've just said that, okay, well, we've stuck this within our quadrant, our second quadrant. But what if I made this and I, pushed it over into the next quadrant right here, where this would have been, okay, and it would have gone right into here, okay, so somewhere along there. Well, in this quadrant, what do I know? What I know is both my x value and my y value are now negative. So now, if your angle is all the way around here and it falls into the third quadrant, which is basically now 180 degrees. So this is 180 degrees plus, whatever angle this might be. Okay, now it's plus instead of a minus. Now all of a sudden, your answers should be actually both negative, because the triangle that you're creating, to create a right angle triangle, it's going to be this triangle. And if you have this triangle right here, okay, like that, now, okay, your opposite, adjacent, okay, and hypotenuse, so all of those, so the adjacent side, so the adjacent is negative because it's pointing this way. The opposite side, which is down, now it's pointing down, so it's also negative. So in this case, what you will find is that if you want the sine of an angle which is actually greater than now 180, you're going to be adding this, okay? Then in this case, your sine is going to be negative of that particular angle, of that complementary angle right here. So that's your theta right there. Okay, so if you want to find that angle all the way around. And what your cos of 180 plus the theta is also going to be negative of that original complementary angle. Why? Because cos is pointing to the left. Now, again, if you think about ratios, remember that ratios are supposed to be the ratios between the lengths of the sides. So it's impossible for the answers to be actually negative. However, in order for us to be able to distinguish between angles that are between 0 and 90, 90 and 180, okay, 180 and 270, and then so on, we actually have to insert these signs in front so that we don't confuse them and know exactly, okay, which angle are you referring to? All right, so this is what we have. And then finally, our tangent of 180 plus the angle, well, that's just sine over cos. They're both negative, so that means that my tan theta will stay positive because you have a negative divided by a negative within here. So that is your second kind of identity that you have, and that is when your angle falls in the third quadrant. So if I go back here and I take the angle, let's say, okay, so if I would take, and I wanted to know what the answer to this is, so let me copy this down, and I'm just going to show you. So I'm going to bring this down here. So what is the answer? Well, the answer is, well, this is definitely in the third quadrant, and it is equal to 180 plus, well, 210, which is going to be 30. Okay, if I add it to 180 is 210. So here is your angle. So this really just equals to the negative of cos of whatever cos 30 is, right? So that's what the answer would have been. Now, we know what cos 30 is, okay? So within here, so this is going to be negative. So cos of 30, again, okay, because that's a common angle. So that ratio that you have within there is going to be, this is square root of 3 over 2. That's what you have. And you can actually enter this into your calculators if you're allowed. So if I go back here, let's say I'm going to just show you. So cos of 210, notice, first it's negative. Now, of course, this doesn't give you a ratio, it actually gives you a decimal number, right? But it is negative, and it's 0.86666. Now, if I'm going to clear this, if I take, okay, so this is square root of 3, and then it's supposed to be divided by 2, well, this is your 0.8666, and it's still negative, right? So you can use your calculators for these, but you should also know that that's how they were actually defined. They were defined by the complementary right angle triangles with respect to the x-axis that is carried out. Now, the last one is, what happens if they fall in the last quadrant? So what if my angle now, so this angle and this arm just keeps swinging around, let's say, and it goes all the way here. And now I am referring to this angle going all the way around here. okay? And now I'm going to make a complementary angle, let's say this. So in that quadrant, what this is, the actual fourth quadrant, it is 360 minus whatever that complementary angle is. And in this case, again, you can just reference back, and you know that in here we have our, okay, so the x value is positive, okay, and then the y value, which is down, is negative. And that's how I remember these. I basically remember them just simply by the quadrant values. And so here, you know, your x value is always your sine, okay? Sorry, it's always your cos. I apologize. It's always your cos and sine because it's your opposite, okay? So it's the actual height, okay? And that is your sine, actual sine, okay, that you put, so positive or negative. So finally, so what we would have is the last one. So sine, cos, and so on. So if I take my cos of 360, now it's going to be minus theta in here. Sine of 360 minus theta. And tangent of 360 minus theta. So now within here, so this is when you're in the fourth quadrant. So now think, okay, so this is going to be positive of whatever angle. My sine, okay, so that's down. So this is going to be negative, okay, of that. And therefore, my tangent, which is just sine over cos, this is going to be also negative. And this is your last identity. Now, you might think, oh my gosh, this is so much to remember. But what I suggest is remember it in terms of the x and y and your quadrants. Because you're familiar with the quadrants. You know which quadrants, okay, the x and y values are positives and negatives. So positive, positive, negative, positive, you know, negative, negative, and then you have positive and negative in here. And remember that the x value kind of represents your cos, and then the sine value represents your, your y value represents your sine. All right, so for this last one, so last example, so tangent of 300, so what is tangent of 300? So if someone asked you, well, tangent of 300, so I know that that is in the fourth quadrant. So I'm going to write it out. This is 360, basically minus 60 degrees. So in this case, so notice it's going to be negative of 10 of whatever 60 is, right? And now 10 of 60, so this is really just sine, okay? So sine over cos. So that's what we have within there. And then you can just check, okay, this is going to be, okay, the square root of 3. All right? So that's what you would have, okay? And again, you can just pluck it right back in here, okay, whenever if you are allowed to use your calculators. Sometimes you're not. So let's say if you do that, okay, you notice that that's what you would get. Negative 1.7320 and so on, which is indeed, okay, so here, square root of 3. All right, and of course negative. Okay, so now rewatch the video if necessary. You know, try to see, put down comments, okay, if you have any questions, if you're unsure about something. I tried to present this to you, these identities, you know, with 180 minus, just basically going through every single quadrant. You know, what happens in those quadrants and then what you should think about. Because really, you only have to remember the first quadrant values, and all the other values for your angles are just remember what's positive and what's negative, and use the x and y to check that. All right? Okay, thanks for watching. See you in a future video. Bye, everybody.